start recording. So, sir, all is done. So you can please start. You and Zishan is co-host, so you can mute everyone or do anything you want, even sharing your screen.
Thank you so much.
Okay. So do you want to start, sir, please?
No, you can go ahead and start, and I'll just intervene and basically give you cues just to have a conversation.
Okay. Okay. So in our previous class, we were in the tutorial, we completed the topic related to the arrays, and in today's class, we wanted to move to the next step. So let me first share my screen. Just a moment. Okay. Okay, so we ended up to the arrays last week in the last class, and today we have to move to the enums and the structs, and moving forward, enum, struct mapping, and all those things. So we'll be talking about these features of the solidity. Okay, so first of all, what the enum is basically. In solidity, we have a much larger benefit of enum, but generally, when we wanted to keep values like it should be the stages or states of something. Whenever you wanted to make a state of something, let's say in this example, they are saying fresh juice. So either it's a small, medium, or large, or in any case, let's say you have a software in software management. When we do the state of a project, we say it's in progress, it's in design phase, it's in a building phase, it's in a testing phase, it's in a deployment phase. So whenever we wanted to make in states of a particular thing, said but object is in particular state, then we wanted to use things like a string which can identify the state. So we say word like in progress. So making it a string will be costly for the memory and the storage as well, because we have to keep the properties value in double quotes, say in progress, in double quotes says deployment, in double quotes says design phase. So these are the string values whenever we wanted to maintain them, and then we have to do the comparison. So comparison will also be based on strings. Enums are the special type of data types where we actually name the variable and we can use those variables, but actually behind the scene, these variables contains numerical values. So if you see in this example, we are creating an enum named fresh juice size, and we are saying small, medium, and large. Assuming if you wanted to do it with the string, then you have to keep this small, medium, and large in double quotes. And whenever you wanted to compare, you will comparing the two strings. So string comparison is the costly. And coming to the solidity, we have an even bigger problem in comparison, because we have to do string does not have direct facility for those comparisons and all those things. So here we have much greater advantage of using enum size. So what will happen is whenever you create a data type like fresh juice,
तो ये चीजें सीखकर
small,
बाहर ब्रिटिश हिस्ट्री में पढ़ने जाएगा तो ये सब चीजें उसके काम आएंगी और
maybe someone is please
Kindly mute everyone.
just a moment. Mute. Okay, so Sajja, you can unmute yourself. Okay. Okay, so the problem is we wanted to maintain, or we wanted to keep the kind of a state of any object or any system, but to maintain those states, what we have to do is we have to do the string comparison. So that's why the enum plays a big role in this case. So if you see fresh juice size, small, medium, and large. So now whenever you create this data type, small will have a value behind the scene 0, medium will have a 1, and large will have 2. So 0, 1, 2, and you can keep going on if you say the extra large and everything. So it will be the 0, 1, 2, 3, 4, 5. And the good thing is you can easily use these data types. Usually you can easily compare those data types, and it will be the numerical comparison. So it will be less costly to your system as well, your memory as well, and it will be easy to manage as well. So let's say, let me take this example, and I'll give you the another example in our case. So what we have to do is we have to first call enum, and I'll keep this value as it is, the name. Now small, medium, and large. For our example, maybe we can use the extra large. So what we are trying to do is we're trying to create multiple state of a juice glass or juice bar. And then what we wanted to do is whenever we wanted to use it, let's say in a function, or we wanted to create a property of it, let's say in function. To create the variable of enum type, what we can do is fresh why I'm not getting this. So we have created a data type name. Okay, sorry. Fresh juice size, and when we wanted to create the value of it, so for us it is like int or uint 256 abc equals to 45. So uint 256 is a data type, abc is a variable, and 45 is a value. We have created the enum fresh juice size. So fresh juice size is a data type, it's in uint 256. abc, we have a juice size, and then value 45. For in our case, because there is no constant values like 45 and 60, it's in a especially type values. Okay. Just a moment. So what we can do is we can use fresh juice dot small, fresh juice dot medium, or fresh juice dot large. That's how we'll create the variable, and we can return this enum property from the function, and we can accept it inside the function as well. So this is the data type. Now what I'm trying to do is I'm trying to create a state level variable. So what I'll do is fresh juice medium. That's the state level variable, and get juice will return this variable. So we'll just call the return here. In update juice size, what I wanted to do is I wanted to change the size of a juice. Now we'll be sending this information from outside of this contract. So we'll be calling from JavaScript or anything else. If we are calling from JavaScript or anything else, what we'll be accepting in our function, we'll accept it as a fresh juice. So I'll accept it as fresh juice. But how we'll be sending this information, that's important. So we'll see. And what I'll do is juice equals to underscore. Okay, so we have this variable, and whenever we want it, we call get juice. It will return us this variable, and it will be the numeric. So for medium, in our case, it will 0. We'll receive 1 in return. And when we'll be updating, we'll also be sending the numerical value. So let's come to this. Let me just compile it first. So okay, so must be restricted to view. It's just saying that as we are not doing anything else, so it in a view state. And in the deployment, what I'll do is I'll call the soliditery.get choose. Let me start the local node. I have already explained this process of setting up a local node and starting it up, so I'm not explaining it again, as we have already seen it in pretty detail. Okay, so you can see the value we receive is 1. Why? Because it is returning us as a numerical value. So inside the contract, you can use it as an enum and manipulate it as it is. Sending it outside of the contract to the external world, to JavaScript or anyone accessing the contract, we can use it. It will be uint 8. So the data type for this enum is actually uint 8. Behind the scene, the number stores inside it. Now, if I wanted to update this, so what I'll do is I'll call solidity test dot update juice size, and I'll send 4. No, 0, 1, 2, 3. It will be updated, and I'll try to check the size again. Okay,
Sir,
so
I have a
that's
question.
1 and 3. But just let me just complete one thing, then I'll take a question. But sending a 3 and expecting a 3 is as it is that yes, I'm sending a 3. So how we can see that really it's working? How? Okay, so how it is working? For that, what we can do is function verify juice size. Here what I'll do is I'll return juice equals double equals fresh juice size dot extra large. So what this function will do is it will return true or false. If juice has a value of extra large, then it will return true. If not, then it will return false. So in our case, before updating, I'll try to call this function and see what it gives us. Okay, I need to compile it for this function to be available. So first we'll check what is the size. It should return false because initially the juice size is medium. It will return false. Then we'll update it to 3. We'll expecting a 3, and then we'll test it again. You can see initially it was false because we are comparing extra large with medium, and this comparison is just the numeric number comparison. It will not require the, if we had to do it with the string values, that means we might need to compare a string like this. Which is more costly in comparison. And once we updated the value, it is returning true. Yes, you had someone had a question.
So this enum will always return as uint.
Uint 8.
And what
If you are yes,
please.
whenever you are communicating between two contracts inside this solidity, then you can expect it or send a value like uint add. But when you are talking with the let's say outside of the blockchain world, from the JavaScript, if you are talking from the JavaScript to the contract, then you will have it as a number, so you can treat it as a number.
And sir, what if we need something to be returned as a string in any case?
You can manage your own string kind of values, but definitely that will cost you. This comparison costs just a simple numerical comparison, but that comparison in string, first of all, it's not easy to do this inside the solidity, because comparison you need to convert it byte and convert it to the some other functions which I'm not going to explain at this moment. Then you will be able to do the comparison. That will cost you the gas. It will cost you the time, which is the important inside solidity for us. So comparing two number will be easy here.
Thank you, sir.
So you can do with this string, but that will be the difficult one. Yes, Shayan.
I also have
So-
a question.
Mhm.
I also have that I know that it is difficult to do comparison in strings, but as when we are comparing, it's a read function. So read function
Mhm.
doesn't cost gas.
Mhm.
Does
I
it cost
agree.
gas if we do it with JavaScript?
Yeah, but for that you have to keep these values at state level. Otherwise, what we will be what we will be comparing with string.
Like no,
You have to store.
I know that
Yes.
it's difficult to do in string. It's very correct that we should, if we are comparing, we should do in enum. But I am just asking, if we call a function from JavaScript, so should
Mhm.
do we have to pay gas?
No, no.
Oh, okay.
But you see, For that, you have to keep a string at the state level like this, which is the storage cost of your contract.
Okay, okay.
Otherwise, you will not be able to compare it. What you will be comparing with.
Okay.
Okay, so that's the simple thing how you will be using the enum. So there is something enum, but how what roles it can play in creating our contract or somewhere or what we are doing. So one of the best example is I was working for one of my customer to raise a fund for NFT, and for that what we wanted to do is we wanted to raise the fund in traditional way, like in stage. So first round will be the seed round, second round will be the private round, third round will be the public round. So we wanted to do the fundraising in the state different rounds. So for that, this enum is very useful for us. That, like, let's say funding rounds, and what I'll do is seed, private, public, and if we have more rounds of raising a fund, and then we can manage it. So now we have this uh, round information here. What we can do is we can say that uh, funding round at this moment, let's say there is nothing inside it, or we can initially set the round to funding round dot seed round. Now what we can do is whenever we wanted to check which round we are in or what current round is, we can say that and I'll connect it with the next example structs. I'll connect it with the structs, so it will be easy to for you guys to understand how it will be things when we learn all the tools and how we can combine them to use in for us. Okay, so funding round return, I'll say it current round. Let me name it a current round. So this will say the current round, and what we can do is we can say function dot change round, and we can expect directly a funding round here, and we'll say the current round equals to underscore round. But first we have to check that if our round is one from the existing. So let me say require now it's our hand how we wanted to compare it. So we have a two option. First one is, let's say I can say funding underscore round equals to funding round dot seed, or round equals to funding round dot private, or let me move it to the down. Public. If the round person is sending is seed private, so why we wanted to do is we have created the contract, and now from the outside when we are in seed round, we'll say that activate the seed round, and then we'll start minting or doing something for the seed round. Syed Hafi, please don't try to write on the screen. And then when we wanted to activate the private round, we'll send the private round. But because it is something from the client, we'll be sending any number. So someone can send 10, 20, or 30. So we have to restrict that information, that it should be only seed, private, or public. So I'll say invalid round.
Zishan, can you please remove this and disable yourself, because your screen is shared, so I cannot disable myself. So you have to make an effort once.
Okay, so I can
You consider drawing.
clear all drawing and
Okay.
I'm unable
Disable
to see the
participants
disabling option. Okay, just a moment. Do we where do we have in okay, yes, disable annotation for others. Okay, thank you. I did it.
Also mute everyone once.
Okay, it's already muted, I guess. Okay, so now what will happen is I can, whenever I'll ask the current round, it will give me the 0, 1, or 2, which is coming from this current round. And whenever I wanted to change the round, so what I'll do is I'll send the information from the client side 0, 1, or 2. If I'll be sending the right information, then the round will be updated. If I'll send the incorrect information, it will raise an error and the transaction will fail. So let's say, let me comment out all these juice information. And what I'll do is, first of all, let me check console.log. What is current round? Current round. Everyone is muted. Why? Where it is coming from?
So you have to mute again.
I
Mute
have
all
done.
again.
I did it again. Thank you.
Zishan, leave it. I'll manage. You focus on
Okay,
work.
thank you.
So I'll monitor whenever somebody try to speak, especially background voice. So I'll remove mute myself. Okay.
Okay, thank you. Okay, so the current round, we can access this information from here, and let me run it. Okay, so it is saying current round is 0. What we have done is we have said the current round is funding round is seed. So seed is 0, private is 1, and public is 2. So what I can do now is, from the client side, I'll say change round, and I'll send 2. Let's first send the correct information, then we'll see if we provide the incorrect information, what will happen. You can see first it returns 0, then we have updated the round. Now the current round running in our contract is public round. What if I try to send information as 5, which is not exist, it does not exist. So the transaction gets failed, and it says function was called with incorrect parameters. The error should be just something which.
Excuse me, sir. Can I add something?
Yes, please.
Sir, in that function, you are taking input as a enum. So I don't think so. The required statements are I think required statements are useless here because we have already mentioned the input should be of type of enum funding rounds, which is 0, 1, 2.
No, but you see, we are facing the problem here. Transaction reverted function was called with incorrect parameter. Okay,
Yeah.
so
Because if you
yes.
take input as a uint, then required statements make sense here.
Yes, you are right. You are right. You are right. That's what my second example. But this example. So, what's your name? Ali.
Sir, my
Ali
name
Razak?
is Ali Razak.
Ali Razak. Thank you, Ali Razak. So, what as we are accepting the funding rounds. So whenever we send the incorrect information, so Solidity itself, the runtime environment itself is checking that if we are sending the correct information or not. That's why this require is not working at this moment. So so this require will not work. So my second example was what I was trying to do is uint, let's say uint 256 or something, and I'll say again because I'm accepting it as a round, so Solidity itself handle this, but it will not give us the exception whatever we want, but it will handle it by itself, and we don't have to worry about sending the, as Ali Razak said, if I was accepting it as u in 256, then I have to manage it myself. And by doing this, what I can do is, let's keep round greater than equals to 0, and round should be underscore round. Round less than equal to 2. Now what we can do is we can say funding round now we are sending the numeric information, and then we are checking that if it's greater than 0 and less than 2. If it is, then what we'll do is it is a conversion casting, which we have not reached it yet. After the mapping, we have the conversion related. What it is trying to do is it's trying to convert numerical information into enum. Now in this case, we'll face the problem, and it will give us the exception as I was the one I was expecting. See, reverted with the string invalid round information. So that's the exception which I raised from here. So if the information, the round number is not correct, so what you can do is you can use the enum to maintain the state. So whenever this is the one of the example when you wanted to raise the fund in a round. So whenever whichever round you are in, as I initially mentioned, that we can manage the stages or state of a project or a contract or a system with enum. So seed round, private round, public round, this is how you will be using the enums in the case of in the Solidity. Okay, so now let's see structs. So struct in case of struct is basically as contract of Solidity are singletons. Whenever you deploy a contract, it's an object, but it's a single object. And whenever you wanted to use that object, it will be the single object, and it'll be calling all the functions on it. So in object oriented world, when we have a object of a student, so we can create a multiple instance of a student object. In Solidity, we do not create multiple instances of a single contract. So if we have a ERC22 contract or a NFT ERC721 contract or any other contract, so we'll be not be just running around and creating multiple instances of a contract, because creating a new instance of a contract means we are deploying a separate contract. That contract will have a separate address. So what will happen is, whenever you create a new instance of a contract, it will create a separate instance. It will have a separate address. You can call it just separately. It will not be the single contract and single address. So for that, but if we do go with this scenario, we will not be able to manage the information when we have multiple, like we wanted to maintain the list of users. We wanted to maintain the list of users, list of books, or in this example, we wanted to keep the list of books in our system. Or let's say we wanted to store the invoices of users. So whatever the user paying, we wanted to keep the list of invoices. So for list of invoices, we need to have a multiple instance of a same entity. That cannot be done by creating the multiple contracts. For that, we have structs. Structs is a simple object. Actually, it will not be creating an object, but it's in a data type, which we can create complex data type, in which we can use strings, numericals, booleans, mapping, and everything we can keep inside these structs. Let's say in this example, we have a struct called book, and here we have the properties is title, author, and the book ID. So that's the struct. And now inside a single contract, we can keep the multiple books information. So we can keep the 10, 20, or 1,000 information list of books. For that, we can use arrays or we can use mapping. But to create, if you see, we created the book, and how we can create the its instance, or its how we can initialize that struct. Book, round bracket, the first value will go to the first parameter, second value will go to the second property we have created, and third value will go to the third property we have created. That's the sequence they follow. For that, let's say,
So sir, struct is a combination of different data types.
you can say that it's a complex data type, so that we can manage the because int, string, boolean are separate data types, but when we wanted to create an entity which can hold multiple information, so if we wanted to create a student will not have just a name. Student will have a name, age, email address. So we need to keep the multiple. So we need, for in that scenario, we need to have a complex data type, and the structs fulfill that criteria for us. So let's say struct, and instead of using this book example, I'll keep the example of the funding round we were talking about. So funding details, funding round details, and I'll use the enum as well. Just pick it from, just to show that we can use enum and everything inside the struct as well. Okay, so u in 256. Funding required. let's keep first property. I'll start with the other properties. So we are creating a struct which has funding round detail, and inside that what we wanted to have is we wanted to keep the information that how much funding is required, and let's add the funding round. So it will have this information, round information. So we'll say function okay. So what we can do is we can create the funding round like this. Let's say funding required 10,000 and the funding round is so in seed round we require $10,000 or something investment. Yes. Now we need to specify the memory or storage whenever we wanted to create a instance or the type or initialize the type. So we have to say this memory. And there is another catch when we do this. If we wanted to keep the mapping inside the struct, so there is another scenario. So I'll explain it as well in a moment. Okay, so we can create funding the round like this. So let's say we have. I don't want to use mapping at this moment. I'll explain it struct as individually, and then I'll combine it mapping, then struct and enum. All three will be together, and it will be the quite nice example. Okay, so that's how we will be creating the round funding round information, and we can keep it inside the any variable or somewhere. And so creating the round, the struct will be like using this way. And what we can do is we can create an array of structs as we have already seen. So let's say so you can see we have created the struct object, a struct data type, and we have pushed it inside the array. Now what I'll do is let me create 3 rounds. So whenever I'll call this function, it will create 3 structs and add that inside the array. And let me create it as a public variable so we can access it and see details. Let's go to the let me first compile it. As I have named it the solidity 2, so I'm updating these values. Okay, so now what I'll do is await add funding now. So it will just go over and add funding now inside the contract, and the array will be updated, and there will be three values inside the array. Now what I can do is I can check the information console.log. Now, because this is a public variable, so what we can do is we can call it directly, but it, as I have explained in when we were talking about the public private variables, that public variables are accessible outside of the contract, but in kind of a function way, getter function. So all round will also be available as a function, and we can pass it 0, 1, 2. So passing a 0 means we are accessing the first index of element. Passing a 1 will means that we are accessing second index, and the passing 2 means we'll be accessing the third index. Okay, so we have updated the rounds, and when we try to access the zero index of the array, so it has 10,000 requirement of funding, and the round name is seed, which will be the 0. So what output we have received an array. So first one is big number. It's ignoring these two because these properties are available as a direct values as well as with the key value pair. So whenever you try to access struct outside of the contract or solidity contract inside the JavaScript, it will give you a array which will have all these properties as a key value pair. So you can see we have a funding round, and this is the information. It's a big number. I'll show you the value and the round. So what I can do is funding round and the round information. Okay, so these two values will be available as individually inside the JavaScript or TypeScript, and we can handle them as we want. Again, whenever we have this, what we can do is we can call the toString or toNumber. You can see funding round 10,000, round information is 0. So if we try to access, instead of 0, if we try to access the index number 2, you can see 30,000 and the round is 2. So what we are trying to do is we have created the struct with the two properties inside it, and we have created its type by using the values, comma separated values, and it will act like a function. So we call the name of the struct and then provide the values. So it should be in sequence of the way we have created. So the first one is the funding required. So first parameter should be the should map to the funding required value, and second property is round. So second property should be, if we have a string over there, then string should be the last one, not the first one, because that's how the sequence should work in the struct. That's the basic example of a struct, and the next point is the mapping. So I'm combining now mapping with the struct. So in
But
case
sir,
of
in this
mapping,
example, sorry to interrupt you,
yes,
string is
please.
at first, like the example which we are seeing at book, the string is at very first, like title and author.
Yeah, they had three attributes: title, author, and book ID. So what they did is title learn Java, author they name it TP, and the book ID they name it 1. So
I
that's how
just
they use.
okay, but you just told that string should be at very last in the struct, so that's
No,
how
no,
it
no,
will
no,
work.
no, no, no. I was saying that if we'll add another attribute, which may be string name. So because it's a third in the sequence, so it should be the third one.
Thank you, sir. Thank you. Got it. Thank
If
you
it's
so
the
much.
first one, if it's the first one, then it should be the first one.
Thank you.
I have a question also.
Yes.
So what if we want to access the only one like a data or one thing, like we want to see this what is inside the funding rounds in this funding round details, how to get that one only, because here we are getting all the data. We want to get only one thing.
Then you definitely have to, the contract needs to provide that functionality to you. So you have to create a function, something like this. Get required funding for the round, UN 256 round number, and then at this moment it seems to us that zero round will be on index 0, 1 round will be on index 1. So keeping it as it is, what we'll do is all round underscore round number dot funding required. So if contracts provide this functionality, then you can do this. Otherwise, you cannot do this. That's how you will be using it, right?
Okay, thanks.
Okay.
But in
Now,
this one,
yes.
If I'm not wrong, sir, in this one it would return something, not the enum.
No, it will return this number funding required. So it will return 10,000, 20,000, 30,000.
Okay, but actually I wanted to return this any one value from the enum. Let's say I wanted to check only which round it is, only from there. Maybe if it is not relevant, then yes, we can move forward.
Which round it is,
No
so
problem.
you can, instead of, you can return the round, or you can access the current round if you wanted to keep the current round. So that depends how you will be implementing the contract. Now once you have the tools, you can combine them, as I'll combine mapping into it here. I'll combine mapping here, so you can see that you can combine things moving forward. You can add things together and you can keep using it. Once you know the tools, you can combine them.
Got it, sir. Thank you.
Let's say in our example, in this example, I wanted to use the mapping, and one example can be that I wanted to keep the it will not be the as good example, but let's say you in 256, and what I'll do is in the value key will be the UN 256, value will be the struct, and I'll say so instead of using array, I'll use the mapping. And when we are adding this round into the array, what we can do is we can keep the this is not exactly sitting coming together the way example should be, but I'm just trying to explain that mapping and struct can be worked together. So there can be the seed round. I'll add multiple seed round to show you guys. The example as a conceptual domain example will not be work as it is. I'm just trying to explain the mapping and the struct, so they should be work together.
Sir, hello. I want to ask
Yes.
that here you written on the above of mapping funding round details array public all rounds. I didn't understand why are you doing this. I didn't understand what it is doing.
Public all round, which one? This one?
Above one, the
This
array
one?
one, funding round detail above the function, above the mapping,
Yes. Yeah, this one.
above the mapping. Yes.
This is the mapping
Line
and
number
this is the
90.
funding round. Okay.
Line number
Yes.
90.
Yes. So
I didn't understand what are you declaring.
I have declared an array. I have declared an array of structs. So array can be of type int, array can be of type number, array can be of type boolean, array can be of type string struct as well. So I'm creating, let's say you wanted to keep information of 20 students in a class. So for that you create a struct of a student, and how you will be managing that 20 students, you have to create an array or a mapping. So I have created this array for this struct. So there will be a 20 30 whatever amount of structs you wanted to add in a function, in a array.
Okay.
Is it clear?
Yes.
Okay. Now in case what I'll do here is I'll say funding round counter. Now you can see I have did the plus round counter. So the very first information will store the key will be 1 and value will be this struct. Key will be 2, value will be the second struct. Key will be 3 and value will be fourth struct. Because in case of array at this moment, it for us this example seems to be that array is working very good and very fine because we have round 0 1 2 3. But in actual if we have a 20 30 or 50 or 1,000 users, then it will not work for us how it should be. Then the mapping is the good example for us. So when we wanted to use a functionality like this, we'll be using the mapping. So we can
right now we are storing struct inside a mapping. Yeah.
We are storing struct inside the mapping, and inside the struct we have the enum. So these properties can combine together and we can add them together however we wanted to do this. Let's say just to red add round, only keep the round, and we'll ask this information. So we have a round counter. What we'll do is round counter plus. That's how you can add this inside the mapping. So data will be coming from the outside. When we'll be calling add round function, will provide the amount and round, and then we'll add it inside the mapping. That's the one example. Or what you can do is you can keep this information in front of each user. So the one who calls this function is available inside the, so let's say we create a mapping address funding round details, just to show all the combinations. Whenever we have this, we can use all these combination user rounds. So what we can do is whenever someone calls this function, we'll say user rounds message.sender equals to this. Now what will happen is we can store round in front of a user who is calling this add round function. And whenever we wanted to access that function, we'll say, let's say, we don't have to give any information about the round. What we'll do is just return user round message.sender. Now the advantage we have is whenever someone calls the add round function, as we have seen in our previous class, first or second class, that we get the message.sender. Whoever the calls this add round function, we get the address of that user inside message.sender. So what we are trying to do is we are trying to keep the mapping. The key will be the address of a person who is sending this information, and the value will be the struct. So when this information stores like this way, it will be easy for us to access information of a particular user. So whoever calls this get my info function will, what we'll do is inside the user round, will send the message or sender, and it will return the value funding round detail. So it will be available outside of this function to us. So that's how you can call the create the struct, add those structs and call those structs, and that struct as well will also be available exactly like we were using the in previous example in this funding round. That's how it's the structs and mapping and the enum all together work all together. Is there any any questions? So if not, then I can move forward.
I have a question that
Yes.
I have I don't understand why do we use memory?
Memory. Basically, the struct object, it's a complex data type. And whenever we wanted to use inside the function, previously there was no such restriction. Maybe in Solidity 4 or 5, you do not have to mention memory. But whenever you wanted to use inside the function, you have to explicitly mention that I'm using it as a memory level, so it should be destroyed once used. When you create the struct at the instance level, then it's in a storage data type. So in the storage level struct will store inside the blockchain. It will be take the state, it will take the memory in the blockchain. Otherwise, in memory level, it will create, it will destroy, and once the transaction is end, there will be no memory footprint for this. So you have to explicitly mention that it's a memory variable and it will be destroyed.
Okay,
So that's the language construct. They made it necessary to provide the memory. If previously there was no such thing, and when it was also the memory parameter and it was also destroyed after the transaction gets completed. But now it's explicitly you have to specify this memory keyword.
Nishan, this is also the case with string, I think. Am I right?
Yes, yes. This is also with the string as well. With the string, with the struct, with the bytes, 2-3 construct in the solidity with which you have to mention this memory property.
Also, if
Yeah.
other contracts, if we are returning another contract, we can also specify memory.
I haven't written a contract directly, because returning a contract is just returning an address of a contract. So we don't
Yes.
return the contract instance itself. So address is not address does not require to specify memory or something.
Therefore, you are saying, I understand when you are passing in parameter, you are saying it's memory that it will be destroyed. But now they are also requiring it for returning.
Yeah, because it will destroyed after the transaction anyway, but they wanted to explicitly mention that it is the local variable and it will be destroyed because it is a complex data type. So they keep these restrictions now. Previously, before Solidity, maybe 5 or 6, it was not that mandatory. It was not explicit to specify memory.
Okay, thank you.
Okay, one last thing for this. For that, I'll create this separate structure, because maybe in Solidity 8, this restriction is now we have this restriction. Previously, it was not such thing. There was no such thing. So let's say I'll user info. String name. That's the simple struct. But if I wanted to add mapping inside that struct, so I can add the mapping. Let's say address and okay. So what I'm trying to say that a particular username who has a name and age, and that person receives the funding from this particular address and this particular amount. So in 256, I'll keep the information of the amount that I received 10,000 or 20,000, 30,000 from whom, from this address. So that's how I wanted to use the struct. But the problem is when I'll try to create that, let's say function. So I guess this is the right age for you, or
Of
it's
course,
too high.
perfect. Perfect.
It's too high. Isn't it too high?
It is a little older, but perfect.
Okay, so first of all, what we have to do is we have to specify memory or storage. So let me say memory, because inside the function we cannot say storage. Now the problem is struct contain nested mapping cannot be constructed. Whenever you have a struct and you wanted to use that struct inside the function, you will not be able to create that construct of struct like this, because what I'll be sending here. So for that, it is not allowed. It is you cannot create this in this particular way. So what we can do is we can have something like this: mapping address or a number, let's say. now the memory will not work as well. So what I have to do, I have to specify storage, and then what I'll do is underscore user dot name
Ishana, I did not
That's how
understand
you-
this.
Okay, so the problem is we wanted to create a struct and we wanted to keep mapping inside that struct. So creating having a mapping inside it, you will not be able to initiate or create an instance or a type of a struct like this, because you have a mapping property and you cannot ignore that mapping property. So they directly give you error that whenever you have a nested mapping, till Solidity 6, I remember till Solidity 6.6, it was not an issue. You can keep these two properties and ignore the mapping. It was working fine. But after that, they might have some changes. So what it's saying, that nested mapping cannot be constructed. If a struct has a nested mapping, you cannot construct in this way. So that's the out of the question. This example is out of the question. Now, how we can create a struct object inside a function, how we'll be initiating it. So what I'm trying to do is I have created a mapping. So when you create a mapping and when you call a particular index, if the struct on that particular index that does not exist, they give you the empty object. So now you have the empty object underscore user, and you can initialize information, name and age on it, and you don't have to worry about this, and you can use this as in your example, and you can add more information inside that. Whenever you wanted to call it, whenever you call the add user, it will, you can use it this way. That's how you go. Let's say I'm taking the page. Okay, so the more better example, just a moment. It will clear more. And instead of keeping the 256, I'll keep the address in the mapping key. We don't need counter. Now you see, whoever calls this add user function, I'll use message.sender as a key, and it will return me, if object already exists, it will return me the existing object. If there is no such object, it will return me the empty object, and then I'll add this information, name and age into it. So I'll call this function, so it will add information provided by me. Maybe Anis bhai calls this function, so it will provide the information provided by Anis bhai. Then if I'll call it again with the new information, it will be updated. That information will be updated. It will be overridden. That's the functionality I have implemented at this moment, but you can manage it according to your needs, how you wanted to use it. So what I'm trying to explain is, whenever you have the mapping inside the struct, which you will be in most of the scenarios, you might have such scenario when you wanted to keep the mapping inside the struct, then you have to use this route to handle to create the struct instance.
If we want to change the UN 256 that stores the funding number in the mapping.
In this mapping?
Yeah. Yes. If we want to also change this in the that function.
Basically, you have to understand that this is the runtime example, and I just tried to explain it, what the problem is. What we can do is we can create another function for your scenario. Provide funding.
So in your example of add user, there will be nothing inside the funding received mapping now. Only the data will be saved
Yes,
in the name and age. That's the point.
yes, mapping will be the empty. So now I'm creating a provide funding function. It will say user address, and I'll say the amount I'm providing. So the U in 256 amount. So this user whom I'm trying to provide the funding and how much amount I wanted to provide. So what I'll do is, again, this completely a runtime example. So there might be some loopholes in the example. So we wanted to understand the constructs. So keep that in mind. Okay, so what I'll do is I'll say user info storage underscore user info. That's the that's what we want from users. And instead of message or sender, what I'll do is I'll say I'm wanted to provide the funding to XYZ address and underscore user info dot funding received message dot sender okay. Let me just do not complicate more. Okay, so now what I'm trying to do is I'm trying to say that provide funding. So let's say I am the user, Zishan, and the information available over here, and Anis is trying to wanted to provide the fund, send the funding to me. So I'll call the Anis will call the provide funding function, give my address and the amount he wanted to. From the mapping array, we'll keep the address of user. From the address, we'll access the struct, and inside that struct, we'll call the funding received property, and we'll say that who is sending the information, address. So the function who calls the function, funding provider. Let's say Anis calls this function. So Anis's address and the amount. So that's how you can use this information here.
Okay, now I understand. Okay.
So any further question on this?
So here in this example, Anis Bhai's transferred amount to you, yeah?
Basically, at this moment, again, the transferring amount requires the payable function and everything. So I'm not going into that detail.
Yeah, no, just for the sake of mapping.
Yes, so
yeah.
Anis is sending funds to me. If you try to understand it this way.
So can we initialize any of the struct value to a default value? For example, the age could be initialized to 30 by default for any new user or any new entry.
You're saying this, or it was something else?
Yes, sir. I was saying this. So it would be default value Zia Khan for all of the new structs created unless we update this value. Am I right?
No. Default value is not available over here. You were saying this, no, right?
Yes, I was talking about this default value like this.
No. Okay, so any further question on this? So this covers our enum struct and the mapping all together. And if you wanted to use the struct inside the mapping, that's what we have done here. If you wanted to use mapping inside this struct, that's what we have done here. And we can use mapping inside mapping. That's I'm not going again into this, but you can use the mapping inside mapping. Like, let's say I have an address and then I have a mapping, another mapping, U in 256, and then I have let's say Boolean. So you can create the mapping like this as well. And it's also many a time you might need such kind of a mapping as well. So because As I have mentioned that in Solidity, we'll not, for the longer type of, when we have many instances, many information, let's say we have a 20,000 users. So you will not be creating an array. You need to use the mapping. And then if you are using the mapping, then it will be the single key and value. So if you wanted to keep multiple information related to this, then you need to create a nested mapping as well. In that scenario, you will be using this kind of example. That's another example for the mapping.
Can we nest it one more time?
Yes. It will keep,
And-
it will complicate, but you can do it.
And
But,
what about-
mapping will be in the value, not in the key.
Okay, sir. And one more thing, what about enum inside enum and struct inside and
Yes.
struct?
Enum inside?
Like, can we make one more enum into enum? Like somehow?
Enum itself is enum. Enum cannot hold enum. Struct can hold enum.
And struct can hold struct as well?
I believe
Yes.
so.
Yes,
I
sir.
believe
It
so.
can hold. Struct
Okay.
can hold the struct as well.
Okay. Okay. Who was saying this?
It's Muzaffar with you, sir.
Muzaffar. Thank you, Muzaffar.
You're welcome, sir.
Okay. So that's how. Any other question?
Don't have a question related to this, but I am saying that I am new. So how
Mhm.
many classes I had by missed?
Maybe we have
Almost
done
four.
maybe 2 or 3. It's our third or fourth class. As much as yes, it's our third or fourth
Okay,
class.
so
So you
can
just
are there any recordings?
yes, all those recordings are available, and Sarja has
All these
updated
recordings
this.
are available. I'll post it here.
Okay.
All this.
Sir, I want to ask one thing. I'm getting one error from past 2 days. It's like your ABI is not iterable or something like that. So if you could please go to this scripts file, which is deploy or something.
We can do it at separate time because it's
No.
the class for the.
Okay.
You can
That's
see
fine.
the we cannot take the time for all the students to solve.
No problem
And
at all. No problem at all.
you can
Yeah,
send
I
me
do understand.
on the Discord. Send me on the Discord. I'll in the Discord channel, and I'll
I do
the
understand, sir. No
Discord's
problem.
channel.
Thank
Thank
you.
I'll check that out. Okay, so next we have is conversion. Now again, conversion is implicit or explicit conversion. The way I was casting the map of funding enum over here, where yes, so I'm using the type of enum and providing the value, so it's trying to convert them. So it's trying to convert the UN256 into the type of enum. So whenever you have some data type and you wanted to convert the data type into some other data type, conversion, it requires the conversion. And there are 2 types of conversion: implicit conversion and explicit conversion. Can anyone explain what is different between implicit and explicit conversion? Anyone? No. Okay. So implicit conversion is when you have a data type which is smaller and you wanted to store information from data type to the larger data type. So if you wanted to use uint8 and we wanted to store all the information inside the uint8 into the uint32 or uint256, then it will be easy because you are storing smaller information into the larger data type. So that's implicit conversion that does not require any effort on your end. But when you wanted to do the explicit conversion, so you have a variable which has a data type uint256, and you wanted to store that information into the smaller data type, let's say uint8, then a compiler will not allow you. You have to strictly enforce to the compiler that do it for me, and I'm responsible for the any problem occurs. So that's when you wanted to use the explicit conversion. If you see this example, we have int8 y equals to -3. Now this is the another level of conversion that it's trying to convert from negative to positive. But keep that in mind that uint8 is a smaller data type and int8 is a smaller data type and uint8 is a larger data type. So you wanted to convert from larger to smaller to larger. But because these are two different data types, so to convert them, you need to use the explicit construct. So with whichever data type you wanted to convert in, you wanted to use this. Let's say, let's move to the example. Okay, so I have uint8 a equals to 45, and I have uint256 p equals to 34. Okay, so if I say uint a equals to 45 and I'll say b equals to a. Now what I'm trying to do is I'm trying to store a smaller data type value into the larger data type. That's not a problem. It's called implicit conversion, because you don't have to do anything. Compiler will not give you any problem, and even there will be no any runtime problem, because you are storing the smaller data type into the larger data type. That's the simple one. But if you have uint256 and you wanted to store it inside uint8, then you will have the compilation error that you cannot store. You see, uint256 is not implicitly convertible to data type. So what you can do is uint8 just compile it first. Okay, so now if you we call the apply conversion. Yeah. So it's 45 even after conversion, which is not a big deal. It's simple. We have a 45 inside the U into 56, and 45 can be stored, can take place in within the size of U in 8. So that's not a problem. But if I'll use the 450 instead of 45, what will be? You see 194. Now where this 194 comes from? The problem is U in 256 means they have a 256. There are many bytes, many bits inside the data type. We wanted to store the information inside the uint 8. So what it will do is it will pick initial 8 bits from this larger data type and use inside the uint 8. What will happen is, because the 450 is a number which can store on multiple bytes instead of single byte. So 450, let's say 450 will store on 2 bytes. So if 450 can store in 2 bytes, but we wanted to store it on only 1 byte, so it will, what it will do is it will pick 8 bits from the first byte, and it will store it in the B. Now, once it will try to convert that binary information into the decimal, it will be something different, because we have not picked complete information from that. That's the problem we face when we do the explicit conversion, because we are saying to the compiler that you don't have to worry about it, I am responsible. So whenever you try to do the explicit conversion, what you have to do is you have to be very careful that it does not lose the information. So in this case, it will lose the information. But if we had this 45, we know that this is a very small information and it can be stored into the uint. Then if we are pretty sure, then we can use the explicit conversion so that it can use the less memory inside our system and does not create the problem for us. But whenever you are doing the explicit conversion, data loss can occur in this scenario. Now, there are multiple examples. The one example they are saying, if I'll just show you this one example, and you can go through this page and use all these examples. Just for the one example. And for this, you also need to understand that this document and most of the documentation which is provided by third parties keep deprecated too much, because Solidity keeps Solidity and the team of Solidity keeps updating Solidity too much. So the information you are seeing U in -3, and it wanted to convert it U in 256. U in int 8, it will not, it will give you an error, because that's not allowed anymore now. Explicit type conversion is not allowed from int 8 to the U into 56. So it's explicitly mentioning. Now what I can do is I can say so U into U int 8, int 16 to U int 16. Previously it was allowed. That's why this example is here, that you can convert int 8 to U into 56. So this example in this scenario is not applicable here. But if you run this example, then you will be fine that you will be converting U into int 8 to U int 8. And for these kind of scenarios, what you have to do is there is not a single source of truth available, a single source of truth available on the Solidity documentation. But if you see some example, some statements on the web, on some article, and you try to run and that does not work, then you have to try some examples, or try to run it, or try to find it why it is not working. then you might see that there might be some breaking changes into the solidity which does not allow it. So in solidity, maybe 8 or 7, they disallowed it from the 8 to the UN 256. And you have, if you wanted to do this, then you int 8 to U int 8 explicit conversion is allowed. Otherwise, it is.
But
And
sir,
if we'll
in
run
this
the-
case, still we will lose the data, yeah?
Yeah, we'll lose the information, but even the thing which you can see in this article, and if you try to pick and try to run it, you will face the problem. You see, you will have 253 because it's -3, so then it applies the 2's complement, and then it will convert to the binary, from binary to the decimal. Then you might have something like in 253. So that's how this conversion is done. One last thing, you can store int values as a hexadecimal values as well. So when you say 0x 1 2 3 5 6 7, that means you are providing this hexadecimal value, and this is not actually stored in this memory. The decimal value of this hexadecimal will be the actual value for you. So you can use this information and you can apply it on your examples. So you can keep information in hexadecimal, compare in the hexadecimal, so it will use the less place into the in typing on all those things. So these are the examples. You can go through them and try to run them. There are multiple examples and multiple scenarios which you need to run and verify. We should not take all the time to use this. At the basic level, you got the understanding that when you wanted to convert from the one type to another data type, if the type you wanted to convert is a smaller, then there is no problem. If it is a larger, then it's a problem, and you will do the explicit conversion and you might lose the data as well. So that's the conversion part of it. And if you have anything related to it, you can ask the next class. That particular example is not working, and we'll check that out. I think we can, what you say, sir, should we move forward or we can stop here?
I think let's, I was thinking, let's see, before functions, we can do it in 2-3 minutes, ether units and special variables.
Special variables we have already covered in the global variables, so we don't have to cover it because that's already covered. These already covered, and the style guide is just the guide that what you wanted to do, the line space and the import, where should be the import. So that's the guideline. We can go for the ether units. So the ether unit is basically whenever you have a financial information, whenever you wanted to store something. So let's say we have a rupee. So each rupee has 100 paisas. Each dollar have 100 cents. So that's how a single unit of number can be distributed or divided into the information. In case of Bitcoin and in case of Ethereum, a single ether can be divided into the 1 raised to the power, I believe it's 8 or 9 something. So it's quintillion million. So whenever you're trying to store the, let's say, just a moment. Whenever we say 2 in 256 amount equals to 1 ether. So you can say 1 ether, but you can also say U in 256. It's 18 zeros, 3, and you can also store them. The good thing about the solidity is you can also store it them like this. It's a valid way to store number inside the solidity. So 3, 6, 9, 12, 15, 18. So you can have 18. So that's the 1. When you say 1 ether, that means it has a 18. I was running an example. Another way to store is 1 E18. So I can say U int 256 1E18. All these are similar. So it's one ether, that's also a one ether, and that's also one ether. So each ether single ether can be divided by the number which is, let's say, if you say I have a.
Hello.
Yes.
We can do it like 1 multiplied by 10 raised to the power 18.
Yes, that's what I'm going to show you over here. So if I say I have 2 ether, so what I can do is I can say 10 raised to the power 18 multiply by 2. So it's actually 2 and 18 zeros, but whenever you wanted to do it, let's say I wanted to have a 5.6 ether. So how I'll be doing it? So 10 raised to the power 18 multiply by 5.6. So that's the actual information that will be stored inside the variable. Now, so we cannot use this comma. And there is, let's say, when we have in 1 rupee, what we have is previously there were a lot of smaller coins inside the 1 rupee. So we have a 25 paisas, we have 1 paisa, we have a 4 paisa, kind of different numbers inside the 1 rupee as well. So we have 50 paisa, we have 75 paisa, exactly like this. In ether, the smallest unit in the rupee, we have 1 paisa. Smallest unit in ether is Wei. We call it WEI Wei. So 1 Wei equals is 1 divided by 10 raised to the power 18. That's how we get it. And if we have the that's how we call the Sasbo. There are many names, Fanny and ether. So you can find the ether. Yes, here you can see. You see 1 Wei, K Wei, M Wei. So when you say the 1000 Wei, that means 1 K Wei. When you say the 1 million Wei, so smallest unit is Wei. So whenever we in a rupee, whenever we say 200 paisas, that means we are talking about the 2 rupees. Whenever we say the 50 paisas, so we are talking about the half rupee. So that's how you in the ether as well, what you say is, what you can do is, the smallest unit is in Wei, and whenever you wanted to work with the ether value, so you can use the maximum number for the 1 ether, which is 10 raised to the power 18, and you can use it if you wanted to use lesser information, let's say 0.5 ether. So what you will do is 0.5 multiplied by 10 raised to the power 18, so you'll get the 0.5 ether. So you have, let's say 10 raised to the power 3, so you will get the 1000 Wei. 10 raised to the power 6, you will get the M Wei, which is 1 million Wei. So 1 million Wei, what will be the ether? So let's say if I have 1 million Wei, what I can do is I can say I have 1 million Wei, divide by 118. That's what the ether I have. That's the amount of ether I have. 0.00001 ether I have. So whenever you see that you are receiving an ether 0.0001, that's the calculation we have. So if I say I have 1 billion Wei, I have 1 billion Wei. So how much ether I have? So let's say 1 billion. No, it's 1 trillion. it's not billion, it's trillion. So I have a 1 trillion way. So what I'll do is divide by, so that's what I have. I have 0.00001 ether in my pocket. So whenever you wanted to handle the Ethereum information, so always remember that ether is 10 raised to the power 18. So whenever you wanted to calculate something in the term of ether, so you have to come up with the information that 10 raised to the power 18 and then multiply it, so you'll find it in the value of ether. So that's how you call it. So these are the name for different units within the ether, like we have in the dollar, like we have in Pak rupee, and that's what we have in the ether as well. So this thing needs to be remembered whenever you wanted to calculate something, like I have mentioned here. So if I say sending an ether, if I wanted to, that's what you should see how we can call it. So const ABC, const ether value equals to. So when I say 1, that's not one ether. If I wanted to send that information inside a function from the JavaScript, from the TypeScript, so what I have to do is I have to call it like ethers dot util dot parse ether, and I'll send 1. What will happen is, so let's say, just let me just comment everything out. Ether value. So JavaScript cannot store that much of a number, so that's why we have, you see, it's 1 and after that 18 18 zeros, so it's 10 raised to the power 18. So whenever you wanted to use 1 ether, 0.5 ether or 0.6 ether, and you wanted to send this in a particular contract is accepting the amount in ether. So you wanted to convert it, either you can do it directly by yourself, or you can call it ether.util.parse ether and pass it 1. So it will actually create the big number, and big number will have the actual ether value for the 1. So let's say if I'll give this 5.6, it will convert it the 5.6 ether, and you can manage it in your way how you wanted to use it. Same goes for the vice versa. If you have, let's say, ethers dot util dot format ether. So let's say I have this ether value. So how much ether it is, I don't know. So I can send them over here. So it's 0.0001 ether. So that's how you can play around with these information. See, that's 100 ether. So I have added too many of zeros. That's why it's become 100 ether. So you can play around with these information. Always remember, inside the Solidity contract, number of ethers will be in way. So when you send 1 ether inside the Solidity contract, it will be 10 raised to the power 18. If you send the 100 ether, it will be the 10 raised to the power 18 multiplied by 100. That's the information will be inside the solidity contract. So contract will have always information in weight. That's what it
So
says.
in contract,
And
in contract, if we put like 1, then ether, then it will be converted to ether. Yeah.
yes, that's what I mentioned over here. 1 ether. And for one last thing, for times, if we say 24 hours, we have multiple information over here. 1 second, 16 seconds, second, minute, hour, day, and week. So whenever we say 24 hour, it will convert it to the times into seconds. So again, it will be the smallest unit. So Solidity keeps the smallest unit so that you can easily play around with the information. So whenever you say 24 hours, that means 24 hours multiplied by 60 multiplied by 60. That's the second inside this variable. That's how it's managed. So when you say the 7 days, so if you have a 1 week, 7 days, these information. So if you say 1 week, that means you are saying 7 multiplied by 24 multiplied by 60 multiplied by 60. That's the information of second, which will be stored here. Okay, so that's how you can store your time information inside it. So however you wanted to manage it, let's say you wanted to do something after 7 days, so you can keep this and the block time stem concurrently, and you can manage it. We'll see if we come across such example.
Okay,
So that's about the. Yes, sir.
Next time we will start covering the functions and
Yes.
then the contracts.
Yes.
Okay. Thank you so much, everybody. Bye bye.